From a young age, we are taught that space is a vacuum, a completely empty void where nothing exists. This idea is often depicted in movies and TV shows, with astronauts adrift in silent, desolate expanses. While this image of space as an empty, airless environment is partly true, it doesn't tell the whole story. The reality, as is often the case with the universe, is far more complex and intriguing. The concept of a perfect vacuum, a region entirely devoid of matter, is primarily a theoretical construct. In reality, even the most extreme vacuums we can create in laboratories still contain a tiny number of atoms. So, how does this relate to space? The vast distances between stars and planets are indeed much emptier than any vacuum we can create on Earth. Yet, calling space a complete vacuum is a simplification. It's essential to delve deeper into the science of vacuums and the nature of space to understand why. In scientific terms, a vacuum is defined as a region with a significantly lower pressure than its surroundings. This lower pressure occurs because there are fewer gas molecules present in a vacuum compared to the surrounding environment. Think of a balloon. When it's inflated, it's filled with air molecules that exert pressure on the balloon's walls. If you were to suck the air out of the balloon, you'd be creating a vacuum inside. The pressure inside would decrease as the number of air molecules decreased. A perfect vacuum with absolutely zero pressure would mean a region with no atoms or molecules at all. While we can get very close to this in laboratories, achieving a true perfect vacuum remains a significant scientific challenge. This brings us to the question, if even our best attempts at creating a vacuum aren't perfect, what about space? Space, especially the vast interstellar and intergalactic regions, comes closer to a perfect vacuum than anything we can create on Earth. This is because the density of matter in space is incredibly low. In these regions, you might find only a few atoms per cubic centimeter, a stark contrast to the trillions upon trillions of atoms packed into the same volume of air we breathe. The low density of matter in space results in extremely low pressure. This near-vacuum environment has profound implications for how objects behave in space. For example, there's no air resistance in space, which is why spacecraft can continue traveling at a constant speed without needing constant propulsion. However, even with its extremely low density, space isn't entirely empty. This is where the concept of particles in space comes into play. While the vast distances between stars and planets may seem empty, they are actually teeming with a variety of particles, each with its own story to tell. These particles, remnants from the Big Bang and energetic events like supernovae, hurtle through space at incredible speeds, creating a cosmic sea of invisible activity. One type of particle found in space is the neutrino, a ghostly particle that barely interacts with matter. It can pass through entire planets as if they weren't even there. Then there are cosmic rays, high-energy particles that bombard our planet from distant corners of the universe, providing valuable insights into the universe's most powerful events. This cosmic sea also contains a faint glow of light known as the cosmic microwave background radiation. This radiation, a remnant from the Big Bang, is evidence of the universe's hot, dense beginnings. These examples highlight that while the density of matter in space is incredibly low compared to Earth, space is far from empty. A matter of perspective. Comparing space to a perfect vacuum. To better understand the difference between space and a perfect vacuum, imagine a vast, dark ocean. A perfect vacuum would be like a single drop of water removed from this ocean, leaving behind a truly empty space. Space, on the other hand, would be like this vast ocean with a few scattered islands. The ocean itself, representing the vast distances of space, might seem empty at first glance. However, a closer look reveals the islands, representing the particles and energy that do exist in space. While the islands are minuscule compared to the vastness of the ocean, they still exist, and their presence changes our understanding of the ocean itself. Similarly, the presence of particles and energy in space, however sparse, has significant implications. The vacuum's influence implications for space exploration. Understanding the true nature of space is crucial for space exploration. For instance, the vacuum of space affects how spacecraft are designed and built. Without air resistance, spacecraft can maintain their speed without constant propulsion. However, this also means that even tiny particles like micrometeoroids can pose a threat, as they can collide with spacecraft at high speeds. The vacuum also influences how astronauts work and live in space. The lack of atmosphere means they need pressurized suits and spacecraft to survive. Furthermore, exposure to the vacuum of space can be dangerous, as it can cause fluids in the body to boil and gas bubbles to form in the blood. Despite these challenges, understanding the nature of the vacuum allows us to develop technologies and strategies for safe and successful space exploration. Our cosmic home, understanding the vacuum for life on Earth. The vacuum of space isn't just relevant to astronauts and spacecraft, it also plays a crucial role in life here on Earth. Our atmosphere, a delicate layer of gases held in place by Earth's gravity, protects us from the harsh realities of the vacuum. It shields us from harmful radiation from the sun and prevents our planet from being bombarded by micrometeoroids. Understanding the vacuum of space helps us appreciate the delicate balance that makes life on Earth possible. It highlights the importance of protecting our atmosphere and the need to explore space sustainably. In conclusion, while the common perception of space as a completely empty void is a simplification, it's an understandable one. The vast distances between celestial bodies are indeed much emptier than anything we experience on Earth. However, even the most desolate regions of space are teeming with particles and energy. Recognizing this fact deepens our appreciation for the complexities of the universe and highlights the interconnectedness between Earth and the cosmos. The vacuum of space, far from being an empty stage, is a dynamic environment that continues to shape our understanding of the universe and our place within it.